I joined the Google Chrome team in 2007 when it was not even 20 people yet. First on security, then infrastructure up to 2019. If you ever use the Google Home Smart Display, then you use the Fuchsia operating system. If you ever use a Pixel branded device, then you use the Pigweed firmware framework. I managed both enterprise teams for these projects until last year. This year, I built the Windows infrastructure for the web browser Arc, which redefines what the browser means. So, ironically, I'm using a Chromebook because I had problems with my Mac. Who has used Arc? Oh yeah, fair number, great. You should try it for the rest. I'm a part-time hardware hacker, a part-time angel investor, but primarily I see myself as a software engineer, and I don't like repetitive work. For example, I don't like raising and lowering the monitors at my desk, like, for example, this kind of standing desk. So, you know, when you change posture and you adjust the monitors. So I wrote a Chrome extension to detect when I lock and unlock my workstation to notify Home Assistant, which then talks to a microcontroller running ESP to raise and lower my monitors. I don't even have to think about it. It just works. I have the most ergonomic setup. And yes, this is my workstation. It's made by MWE Lab from Quebec City. Highly recommended. I own the whole software and hardware stack. My project is the source of truth. I made it. It's mine. I soldered the board. I wired up everything. And the software is on GitHub. If you know, who knows what ESP Home or Home Assistant is? A few, OK. So it's a home automation software. So my project depends on a lot of software created by others and software and hardware engineers who build awesome reusable components. I'm oversimplifying here the stack, but my point is Python 3 as is. Like, I don't need to modify any of these projects to maintain mine. When I write software, I don't start patching the CPU. I don't patch the OS. I just buy an off-the-shelf laptop or a server and use it. It's not true of hyperscalers. For example, Google has been using custom-tailored CPU SKUs created exclusively for them for more than a decade. The CPU is customized to benefit the hyperscaler, and the modifications enable them to their secret sauce in domains like security and observability. It's a matter of scale. The larger the software project is or the hardware deployment, the higher the likelihood that you need to tweak a bit your dependencies. I'd like first to define what a large project is. When people talk about the largest open source projects, often the Linux kernel is mentioned. The Linux kernel is a pretty active project with around 1,600 commits per week. And the Linux kernel uses the git merge workflows. Raise your hand if you know the difference between a merge and a rebase workflow in Git. OK, part of it. OK, let's see what happens when we only look at the merges. Since the Linux kernel uses a merge workflow, the merge commits are the equivalent of a GitHub PRs. Who knows what a GitHub PR is? OK, fair number. OK, good. If you only count the merge commits, the contribution rate is about 130 per week. It's the red line on this graph. It's about 20 changes per day. That's quite a lot. Let's compare with WebKit and Blink projects, which powers Apple's Safari and Google Chrome. The two lines matches up to the fork in 2013. Since they both come from a subversion workflow, they both migrated to a rebase workflow. We can see that on average, the Blink contributions has been a tad higher. It's the blue line. But still, they are mostly within the same range, about 300 contributions per week or 40 per day. Note that I didn't try to filter out like robots commits or things like that. I know in the past, like some people were running scripts to do automated commits at their desk. I hope it's not the case anymore. And let's compare with Chromium. I hope who doesn't know what Chromium is? Okay, everybody knows. Okay, just in case. So the main repository is called src.git. The Chromium project uses a lot of bots to do automated commits. It's the blue line. The red line is the humans. And so humans make about 2,300 changes per week, or 330 per day, or about one every 4 or 5 minutes, 24 hours a day, 7 days a week. The dips in the graph are the New Year's Eve. Software engineers take vacation. That's what I call a large project. Big software projects like Chromium depend on a lot of other projects. And just like my monitor project, they reuse existing software. The Chromium lists them as required by the software licenses. You may notice it's a bit jerky, sorry about that, but you may notice some projects are listed twice, multiple times, because they are transitive dependencies. They are dependencies from other dependencies that Chromium needs. You don't want to reinvent the world, yet you may get into a state where you need to make patches to one of these dependencies. And that's when people start forking. There's multiple reasons to fork. Sometimes it's due to licensing or governance. Examples include MariaDB from MySQL when Oracle bought it, or Jenkins from Hudson when Oracle bought it, or LibreOffice from OpenOffice when Oracle bought it. Yeah, you get the idea. So more recent examples include Elasticsearch, Redis, MongoDB, CockroachDB, Grafana, Terraform. I can go for a while. Who is a fan of The Good Place? Well, not many. OK, too bad. I like the show. So as you figured out, we're going to talk about forks, but also how to not fork. Sometimes fork happens because the owners are not ready to make the project public yet. It happened for both Apple's Safari and Google Chrome. The history traces back to more than 25 years ago, when Internet Explorer 4 just overtook Netscape as the most popular web browser. The history here is fascinating, but before I start, a small disclaimer. While I tried to make this talk grounded in facts as much as possible, I'm not omniscient nor free of biases. This is not a Google good, Apple bad talk. While I was personally employed by Google, I don't believe there were any ill intent on any side. Oh, and first, who knows what KDE is? KDE, sorry. Yeah, 1, 2, 3, handful. OK. KDE is a Linux desktop suite. The project quickly realized that they needed a web browser, and they built KHTML and KGS. The funny thing is that KHTML was itself a fork of KHTMLW, which was created in 1996. In 2001, Apple silently forked KHTML to develop WebKit. And in 2003, Apple made it public as part of the Safari release, as required by the KHTML license. They initially declared the desire to collaborate and contribute back, but it was clear that WebKit will never be merged back into KHTML, and that WebKit would be its own source of truth, driven by business imperatives. It's an important distinction because KDE is free software in the GNU sense, while WebKit is only open source because it's contaminated by the KHTML's LGPL v2 license. In 2006, the browser project created by ex-Mozilla contributors employed by Google started using WebKit. The difference with Apple is that they started contributing patches back using pseudonyms, and there were no intention of keeping it forked. And when Chromium was open source in 2008, all the remaining local patches were either upstream, or we addressed that in the Chromium project itself. Google asked for a ton of structural changes in WebKit in 2008. They wanted to use their own JavaScript engine called V8 instead of JavaScript Core, and V8 was far from being mature at the time. Google asked to fundamentally change the threading model in a way that was not needed for a single process web browser, because the concept of having multiple processes for a web browser didn't even exist at the time. This created a ton of churn in WebKit, requiring the addition of new abstraction layers. Apple really showed willingness to embrace the collaboration, and it lasted 5 years. In 2013, there's been architecture tensions with the trading model. Apple engineers wanted to add asserts for iOS-specific code, and instead of refactoring the iOS code to correctly use WebKit because they said it will take many years. In parallel, in March 5th, Apple was granted the WebKit trademark that they had filed in 2010. I don't personally know if anyone outside Apple was aware of this. Less than a month later, on April 3rd, the tension about the design and ownership culminated in the fork of WebKit. Many non-Apple WebKit contributors stated that they would start using Blink 2, exposing a pre-existing discomfort. So all of this sounds very dramatic. To be clear, there was no good or evil, just people with different incentives. Talking to each other in person often leads to better conflict resolution than over mailing lists, for example. Since most developers from both Apple and Google were in the Bay Area, they met in person to help with increasing rapport and trust. I went to one of these meetings. It was really fun. Ultimately, what is important is to find solutions that meet the needs of each core contributing groups. Starting in 2008, the Chromium testing infrastructure grew extremely fast. I wanted to use these amazing ideas, and hear me out, like running tests before submitting patches. So in October, 1 month after the public release, I created the Try server, taking inspiration from Mozilla's infrastructure to make it possible for developers to test their patches before submitting it. Thereafter, I worked on the developer infrastructure on the Chromium project and created the commit queue in 2010, which automatically merges patches after passing the automated pre-submit test. One of the things that I made sure as part of my job was that our infrastructure will never fetch from WebKit's Subversion server. That was because our infrastructure grew so big with hundreds of workers that if we fetch by accident from WebKit's root source control instead of our local mirrors, we instantaneously killed their servers and nobody would be able to check out or commit to WebKit. So we called it the Chromium CI Ray of Death. Big disclaimer here, I was not personally part of the group that decided to fork. I was looped in because of the WebKit. Forking WebKit meant reconstructing the WebKit test infrastructure on our own. It was a fairly significant endeavor. And someone on the team decided to buy a huge fork. Earlier in this talk, I mentioned in passage source controls. So on the technical side, source control and contribution gatekeeping, what we call code reviews, has a huge impact. Who has ever used Subversion? Oh, wow, more than I thought. OK. Subversion was the state of the art in 2006. At the time, Git couldn't be used by the Chromium team because it didn't work on Windows. On the other hand, Chrome OS used it from the start because they didn't have to work on Windows. Lucky them. WebKit was using Subversion too. So when you fork, the source control system really matters, because forking was destructive on Subversion. You cannot keep a nice history like with Git. Nowadays, most open source projects use Git. Hello, Mercurial. But this was not the case up to recently, as shown with WebKit. So switching, and the reason is that switching to a different version control system is extremely costly. Release management has to be redone, and actually the Chromium project did it twice. We switched from Perforce to Subversion first, and then from Subversion to WebKit, to Git. Okay, what was the impact of forking? Did it help in the past decade, or did it hurt? Again, this is my personal observation, a big disclaimer. I personally believe that Apple at the time didn't have the business incentives to significantly increase the capability of web pages, especially on phones because of the App Store. One can argue that Google didn't have either because of Android. And there were definitely internal tensions about this. But Chrome OS was a key element here. Its leadership really wanted to make the devices more appealing to users. What really changed the development as you know it is, in my opinion, is the removal of vendor prefixes, because otherwise would be right now a huge mess. I believe it was the right thing to do. Similar to how auto-updating web browsers was the right thing to do. And you have to remind, in 2008, it was extremely controversial to have the web browser auto-updating. The other thing that really helped Chromium to make it popular was that you could check out any version, build it, and actually get a working web browser, which is not always true. So often open source projects get broken. But with all the work that I did, I'm really proud to have been able to make it possible. This is because Chromium is dependable. You can use it as a dependency itself. And this is very important for downstream businesses that are leveraging the project. Chromium became an upstream. Node.js and Electron initially were great examples, and also all the derivative web browsers like Arc.
Or Edge from Microsoft.
Or Edge, yes. It also significantly increased the number of non-Google contributors overall. When you have an upstream-downstream relationship, there's a few things that can help make the relationship work, both on the business level, on the technical level, but also on the human level. How can we all meet in the middle? So in the second part of this talk, I'm going to share some hard-earned experiences so you can set yourself for success if you ever see yourself in this situation. The most critical part is the upstream because of the inherent power dynamics. So let's dive into it. First, as an upstream, you need to make sure that the team doesn't burn itself. The absolute self-protection is what I call a code dump. Just don't accept contributions. There's no problems. A great example is open-weight LLMs. Pure publication, no feedback mechanism. But an even better example is SQLite. Who knows what SQLite is? Wow, OK, most of the people. SQLite maintainers save a ton of time because there's so many things they don't need to formalize. You want a feature? Sure, come with a PO. This can work, but it's more the exception than the rule because the project intentionally cannot get benefits from contributors. But one benefit of such setup is that SQLite is released under a public domain license. The license is critical. If you use a viral license like AGPL, be ready to enforce it. A good example in the 3D printer community is Slicer. There's a lot of parallel to do with KHTML. Both KHTML and Slicer had many derivative projects. KHTML is LGPL v2, where Slicer is AGPL v3. The AGPL license has extreme requirements about open sourcing derivatives. So much that I can hear Bill Gates screaming how much he hates it from here. Some companies got caught not open sourcing the code when they released their software, and Bamboo Lab being a prime example. And interestingly enough, they now have a healthy open source project because of this required open sourcing. Slicer had a clear vision of doing one thing well, processing a 3D model and making it printable by FDM printer. You want a clear vision statement associated with your project. In particular, to make it clear what is out of scope. This is extremely important so that folks don't spend time creating abstraction layers or contributions that will just be flat out refused. Sometimes the weight of the new contributor can tilt the balance. Initially, WebKit assumed JavaScript core, and Apple agreed to create an abstraction layer because getting Google on board was worth the cost. But this kind of event is more the exception than the rule. Owning a small project means that everything is in your head and it's crystal clear. It gets challenging when external users want to contribute and misunderstand critical subtleties in how the project is designed or tested. Some projects are notorious for not having any test or CI pipeline. The problem with this approach is that any external contributions becomes a huge liability. If regression is detected down the road, it's the maintainers that will have to hold the bag and repair the damage done. What regression tests and infrastructure do is to shorten the feedback loop and even prevent regressions from happening in the first place. This requires high-quality tests, and it's work. It also requires looking at bug reports and handling them. Again, more work. Regressions are one kind of risk for the survival of the project. Whoops. There's many other risks, like malicious behavior from an external party. A frightening recent example is the XZ project, where a malicious person took ownership of the XZ project and injected broken behavior intentionally to break the SSH server. It took the attacker more than 3 years of social engineering to gain control. Who heard about this story? Oh yeah, fair number. It's pretty wild as of today. We still don't know who is behind this attack. So create contact points for security. If someone finds a security issue, can they contact you in a secure manner? GitHub has tooling to set up a security policy. Try to use it. As an upstream, you have to be prepared on how to handle it. Again, more work. And all this work is starting to become costly. Open source projects range from an old tarball available on the internet to a highly structured project with a ton of infrastructure. Some projects have costs that are adjacent to the source code. Any repository-like project will suffer from that. For each of NPM, Docker, PyPI, Ruby gems, Rust crates, or Hugging Face, they are open source software, but also an infrastructure with huge storage and network cost. The upstream project has to self-protect itself as early as possible, otherwise they'll have to make changes down the road because users cannot free ride their infrastructure anymore. The advent of free CI solutions for open source, including Travis in the good old days, or GitHub Actions hosted runners in the recent years, and CDNs, free CDNs like Cloudflare really helped the lower end. But on the high end, running on free will not work, and one has to be paid to maintain the CI. Oh, and by the way, that's literally my professional job, and you can hire me for that. To take an example I know well, the Chromium infrastructure has tens of thousands of machines. Tens of thousands of machines running tests on a continuous basis. Each test suite takes tens of hours to run and is scaled horizontally to get results within tens of minutes. And it looks like the only PowerPC is sad. That's actually for the Go team. But having sponsors to pay the bill to make the project sustainable is critical for large projects. The project will not survive if there's no money injected in it. And a large project takes time to build, to test, and the free quota offered by companies like GitHub will not be sufficient. Will it be salary to do the boring work, and one has to triage incoming bugs and feature requests? Actually, I'll try to browse live just to show how right now what it looks like. So if you click on there, yeah, it's live. So there's about 31,000 machines at the moment, and for example, if I only took a look at the max, yeah, there's about 7,700 max available. So it gives you a sense of scale of I don't know if you have that many max, but yeah, it's not fun. Okay. So cost management is especially important when the project has a lot of code churn. And churn happens in multiple forms. Some folks will move code around, reformat, and if you didn't clean your code first, someone may come in and try to clean it, not in the way you want it. and sometimes you want to port the project to a new operating system, which also creates a lot of churn abstraction layers to be designed future-proofed. For example, we experienced that when we ported Chromium to the Fuchsia operating system. And all these contributions will increase the CI use, which in some cases can cause issue like exhausting your CI quota. Often folks will send simple PRs just to be listed as a contributor to a project. I don't know if anyone else did that. No, OK. As such, some project bans contributions that are simply only typo fixes or similar. An example is TensorFlow, where non-critical contributions are refused. The rationale is that every single PR is tested internally inside Google's infrastructure, which is extremely expensive given the Google's mono-repo setup. While it's true that it helps protect the project and its cost, I believe that ultimately refusing good contributions, and I insist on the word good, ruffles contributors the wrong way. TensorFlow is a highly structured project with centralized decisions within Google. Not all projects are centralized the same. Very large projects tend to gravitate towards one of two structures. Either one company or a foundation stewards the architecture decision process, or a more diffuse group of people without an official governance. The latter is often a single-owner project that outgrew the original maintainer. Governance is often underdefined, yet critical on the long term. Well-organized projects have a way to signal and document important changes. It comes with many names intended to implement or to ship, RFC, RFD, or PEPs, to name a few. I want to show a few because it's maybe not something you have sought after, and there's treasures there in the well-written design docs that you can learn a lot from. Some are more about organizational issues like PEPs, while others are squarely focused on the technical side. So for example, if I click on the intent to ship, it's really awesome because it is a really simple pipeline which just looks at the Safari, Gecko, and Blink mailing list and generates like a bot that just posts every time there's an intent to ship there on Blue Sky. And then like you can say, oh, like they want to change something about bundles, and then Gecko wants to add that, things like that. Oxide is pretty amazing in the way they do their RFD. For example, one was like, hey, what do we do with Cockroach because they messed up their license? And like they have like a pretty thoughtful discussion about like what they should do about that. And it's pretty amazing. Fuchsia does it directly in the code review system. So it's a bit harder to look at, but if you go directly there, you can see like it's really just Markdown, and then like you can read the design doc online, and it's pretty nice. And finally, the last example is the PEPs. For people that use Python in the past, you may be aware of like the Python enhancements proposals. And then, for example, if you look at the last one, you can see that it's actually about organizational like elections. So like the proposal is not necessarily about a technical or license decision. It's really more like, hey, we want to formalize the election of the new governing structure. Yeah, so that's examples. So as I've shown, most use Markdown and Git to store the data in the backend. Some still use issue trackers like GitHub issues. I believe that TypeScript and Go projects seem to do that. And for historical reasons, web browsers tend to use mailing lists instead. Doesn't really matter. But the thing is that defining a strong governance structure is work. As I said earlier, the best way to avoid all of that is to do a code dump, like SQLite is doing. I discussed a few ways how to create a healthy upstream project. And now, what about being a good downstream user, where like you've seen a great project and you want to participate in the project? Well, first things first, it's really critical to do your homework. And I'll give multiple examples of things that I personally consider homeworks. Learn about the project first, like understand the contributions expectations. The contributors pretty much always come with good intentions. It's been extremely rare to see evil contributions, like for example what XZ project takeover happened. One homework is to understand how to comply with the license. If you use a copyleft license from the GPL family, like you need to publish the modifications. One of the biggest challenges as a maintainer, and I can talk from that, is that all the well-intentioned folks that are learning but come from too far behind on the technical side and are just not there yet to contribute at the expected quality standards of the project. It can be very time-consuming for the maintainers to handhold every single change that inexperienced people want to contribute. It's fine to ask folks to clean their work, but it's much easier when it's software that asks for it. So a good example is enforcing strict code formatting or some linters, and generally the worst contributors will just drop out. Make sure some tests are blocking too, and like you can even crank it up and enforce minimum code coverage. Ask the upstream if they would appreciate such tools. They may decline, and it's important to figure out why. Because the upstream's incentives are not always obvious. Some projects are extremely business aligned, while others are much more engineering-driven. Compare a VC-backed company versus a small JavaScript library ordered by a single person. Both are fine, just figure out what you are getting into. Understand the upstream's project vision to really appreciate what features should be contributed or not, or if an abstraction layer is worth injecting. A great example is when Google made WebKit multi-threaded for its out-of-process renderer. Silent assumptions in the design are often going to be the biggest challenge to resolve because they are taken for granted. It's obvious for the maintainer. It's all but obvious for the contributors. As a contributor, their work falls on your shoulder to reverse engineer the silent assumptions. Maybe contribute a bit of documentation to spell it out. As a downstream user, adding value is often in the parts that the maintainer dislikes doing. While not always the case, but often it's going to be in the documentation, testing, correctness. As you get more intimate with the project, program organization, like triaging issues, reviewing contributions from others, or even maintaining the project's website and discussions forums are generally greatly appreciated. Be there for the long run. And I'm going to mention a success story, is that who has ever used CSS Grid? Oh yeah, but do you know who paid for CSS Grid to be implemented? Oh, actually it's Bloomberg wanted CSS Grid so much for their terminals that they contracted Igalia to define the standards, do the design, and write the implementation on their behalf in multiple web browsers. This work took several years, and it now benefits everyone. The value that Bloomberg provided is money to pay for the work. Huge props for them. In the last 6 years, Igalia employees have been contributing thousands of patches to Chromium, consistently more than Microsoft, even if they are a much smaller team. So thanks for Igalia for making the web better. Even if you add value as a downstream contributor, the drift in vision may lead you to decide that you need to fork. So like you just take the code away. Maybe you are annoyed that upstream dumps 100 changes right after WWDC. Or maybe upstream is just a royal jerk, to separate out instances. What to do when you decide to fork instead of contributing upstream? Well, define your tenets, define your values, and it's really important to clearly define what is the source of truth. The step is critical. There's two kinds of forks. You can either do a soft fork where you continue to track upstream. A good example is all the Chromium-derived web browsers or projects. They have to track upstream because the web keeps on evolving, and we do not tolerate 0 days security issues like in the 90s. You can do a hard fork like WebKit did with KHTML or Blink with WebKit, when you try to keep things in sync, try to keep things in sync for a while, but the chasm is so strong that the projects are determined to drift apart. In the case of soft fork, the first thing is to plan to continue to contribute to keep your fork as simple as possible. Be self-conscious about what upstream will accept or refuse. You need to keep a process in sync to sync up with upstream changes and manage the local changes that are not going to be upstream. I experienced all three ways of doing soft forks, and what you should end up doing really depends. Like for low-intensity project, using merge or rebase is fine, but it doesn't scale for high-intensity upstreams. In this case, often patches are used, and actually I'm going to use the web browser Brave as an example here. So if you look at the number of patches, like there's a few. So in the way they patch the build system is that they create a variable, and then like they just inject like all the sources that they inject there in the build system. So it's pretty short and sweet, and it works well. For the actual C++ code, what they do is that they inject macros that are defined elsewhere. So this way, they create a single one-liner that they inject there. It's a trade-off. Sometimes it's better to have the code in line and like have your patch a bit larger. They decided to err on the side of like making their patch smaller. There's trade-offs involved. You may use a bit of both. But I just wanted to show an example of like how it can be done there. So basically, you commit your patches, and then when you check out, you apply them. Yeah. Good. And actually, I hope it's going to encourage you to become a good upstream maintainer or a great downstream user and contributor. The important thing here is to build. Like, don't stop building. I tried to condense this talk as much as I could, so I left out a lot of details. Please ask questions after or talk to me after the talk. I really love discussing that. So thanks. Oh, that's a great question. Implemented well, I think it's good. I personally use it for my own projects. It's extremely rare. It's really hard, though, because without automated tooling, you cannot do like real semantic versioning, like, and not know if you break users. And actually, I'm personally a Go developer, and someone wrote a blog post proving that any single change in the public symbols will potentially break downstream user. Even like exporting a new function may break downstream users. So in this kind of case, it's tricky. Like you cannot do something absolutely perfect, but I still see a lot of value in that. And yes, and your second question?
And my second question is about should upstream broadcast to the world what is a security fix and what is just a regular change? Because Linux, for example, has a strict policy of not labeling their security patches as security patches.
Yes.
Because they consider that any patch is patches.
Yeah, and it's really a huge contrast. So to repeat the question, so what to do with security patches, and like the Linux kernel doesn't contribute security patches to be different than any other bug fixes. The Chromium project, for example, has a very, very strict way of doing security patches in a way that helps, it enables the downstream projects to be synced. A lot of critical projects have this kind of structure, but it's really more for like really like large projects with strong governance. And I think that the Linux project itself really wants to diffuse as much the governance as possible. So, but like there's multiple reasons of why they are doing that. I believe that when the ratio of upstream and downstream becomes large enough, and like the fan-out starts to be large enough, and that the impact on users is large enough, like eventually a structure has to be created. Otherwise, the cost is just diffused. Like in the case of Linux, like everybody pays the cost of not having a clean upstream structure for managing security patches. But again, it's work, it's cost, and the Linux Foundation is just a non-profit. Like it's not the company that makes money. So I understand like the tensions here.
But overall, the cost aside, which approach is safer?
Oh, the safer approach is to have structured disclosure of security patches. Which doesn't mean like that you should wait 2 months to, like the Chrome patches are generally deployed like within, like every week, literally, like it's weekly security patches. I think it's a good balance of like updating not too often, but still like, no. Because you want towards 0 days. Like the important thing is how fast can you fix a 0 day? And we see companies completely failing at that. So I think that if you're set up in a way that, even if like people are not really working together, if you can fix your 0 days within 24 hours, that's fine with me.
Any more questions? Yep.
What's your take on Hacktoberfest? And do you think that's a good way to like recruit new contributors who are often like junior devs? Like, what do you think is a good way to bring up to speed the new contributors in an open source project?
So I'm not familiar with October.
So Hacktoberfest is basically a event where in a period of a month, let's say, GitHub really encourages people to commit to whatever open source projects are available. Like,
okay. So the question is what do I think about encouraging people to make their first open source contributions?
Right.
I believe it's great. As often people come with misalignment of the expectations and like they just don't know, like they are learning and it's fine. It's just that often they don't really realize how much work it represents to actually contribute a single line of code. And so it's all about like setting the expectations and like communicating that. But the thing is that it's different for every single open source project. So that's why that's why I made this talk. So hopefully like people will watch it and like understand that yes, there is a bit of homework to do when you want to contribute. And it's okay.
One more question? All right, that's it for tonight.
Okay. Thanks a lot.